This is Mission Control Houston. Good morning. You are getting a live look at Pad 0A from the Virginia Space Mid-Atlantic Regional Spaceport off the coast of Wallops Island in Wallops, Virginia. Poised on top of the pad is the Antares 230 Plus rocket. On top of that is Northrop Grumman's Cygnus cargo vehicle and 8,000 pounds of research, fresh food, technology demonstrations, and supplies. This is Northrop Grumman's CRS-15 mission, and the destination today is the International Space Station.
LC GNC-1 OrbNav.
We're currently inside 36 minutes from liftoff today. Time of liftoff is scheduled at 11:36 and 49 seconds a.m. Central Time, 12:36 p.m. Eastern Time. Counting down, that is the opening of a 5-minute launch window for today. Today is February 20th, 2021, coinciding with the 59th anniversary of John Glenn's Mercury flight. He was the first American to orbit the Earth.
Propellant loading operations.
Getting a live look at the rocket, you can start to see some conditioned air billowing off the sides of the Antares first stage rocket. That first stage is already loaded with its fuel, liquid oxygen, and RP-1 kerosene. Second stage is a solid rocket motor. Currently favorable weather conditions today, looking at about 32 degrees Fahrenheit, 0 degrees centigrade, and that we can expect that same temperature at the T0 mark at 11:36 a.m. Central, 12:36 p.m. Eastern. Looking at some scattered deck and cloud ceilings and monitoring some wind gusts, but overall we're looking at about a 75% favorability margin. We are 75% go for launch today.
351, enable your local launch.
Mission Control Houston and the Mission Operations Center in Dulles, Virginia have conducted a preliminary T-minus 2-hour go-no-go poll and are go for launch. They're about to come up on another go poll at the T-minus 30 mark.
Enabled and illuminated.
RSO.
Northrop Grumman's CRS-15 mission is named the SS Katherine Johnson. Northrop Grumman named the CRS-15 after the NASA mathematician, a black woman who time and again broke through the barriers of gender and race. It is a company tradition to name each Cygnus spacecraft after an individual who has played a pivotal role in human spaceflight. Her handwritten calculations were critical to America's success during our first human spaceflight missions. Again, this is February 20th, the 59th anniversary of John Glenn's flight. And when he again became the first American to orbit the Earth, it is a perfect tie to the SS Katherine Johnson. While NASA had used the IBM computers to calculate the complex orbital trajectory, Glenn asked to have Katherine Johnson verify the calculations by hand and would not fly until she gave the go. We have teams supporting from all over the United States for today's launch, counting down to 12:36 p.m. Eastern. Over at the Wallops Flight Facility, you're looking at Wallops Range Control Center, counting down and walking us through these next steps over the next 33 minutes to a T0 mark. On top of the Antares rocket, we have the Northrop Grumman's Mission Operations Center in Dulles, Virginia, monitoring the Cygnus spacecraft on top of that rocket. The teams there are led by Mission Director Zach Dwyer for launch. He'll be handing over to Amy Allison for solar array deployment. And of course, the destination for Cygnus after its day and a half in orbit will be the International Space Station. Mission Control Houston standing by and watching the launch and monitoring the operations of the International Space Station in flight. Flight Director Scott Stover is here in the room and just gave that T-minus 30 go for launch from Mission Control Houston. Visiting Vehicle Officer working with teams in Dulles, Virginia is Jessica Doy. Now, of course, the primary job for today is watching for the launch and making sure everything is go for launch, but we do have 24/7 hour operations for onboard International Space Station operations. We are in a weekend, but the crew on board is enjoying a day off, a day of cleaning, and some exercise, and of course they'll be watching today's launch. From left to right, we have the Expedition 64 crew, NASA astronaut Kate Rubins and NASA astronaut Victor Glover, Japan Aerospace Exploration Agency Soichi Noguchi, and then ISS Commander Sergei Ryzhikov. We also have NASA astronauts Mike Hopkins and Shannon Walker, and rounding out at the very right side is Roscosmos cosmonaut Sergei Kudzverchkov. Again, we just came to Mission Control Houston while polling a go for launch at T-minus 30 minutes. Currently tracking no issues with the Antares rocket either. And Mission Operations Center in Dulles, Virginia is also tracking everything is healthy with the Cygnus vehicle on top. Now coming up on 30 minutes to launch. Joining us for today's broadcast from Northrop Grumman, we'll be welcoming Christina Halona, Antares Systems Engineering Program Manager, to walk us through some of the features and milestones for today's launch. Christina, welcome.
Thank you, Gary. I'm happy to be here and welcome all of you watching here in the United States and around the world to see a successful Antares launch and Cygnus mission to the International Space Station.
Wonderful. We're getting a look at the pad now, looking at the Antares rocket, billing off some conditioned air. Tell us about this rocket, Antares 230 Plus.
Yeah, so Gary, the Antares 230 Plus vehicle is an upgrade to our previous Antares 230 vehicle, which was under the previous CRS-1 contract. This NG-15 mission marks Northrop Grumman's fourth cargo service under the CRS-2 contract, with NG-12 being our very first Antares 230 Plus mission, which was flown in November of 2019. The differences between the 230 and 230 Plus are the upgrades to the Stage 1 core, which has lighter composite structures and an optimized second stage motor. The upgraded Stage 1 core allows Antares engines to perform at full thrust throughout most of the first stage profile. The 230 Plus vehicle also has a cargo mass flexibility in which the Cygnus mass can be defined with agreed upon constraints, of course, but no later than 24 hours prior to launch. So speaking of cargo, another capability of the Antares 230 Plus rocket is that Antares can perform late load operations by the unique pop-top fairing and specialized ground equipment. If you look closely at Antares, you can see the nose of the rocket, and you'll be able to see the little pop-off that we have there, and that can be removed for the late cargo load. And Antares having the ability to do a late load cargo load 24 hours before launch, we're able to support critical research experiments for NASA. And with all this talk about cargo, the Antares vehicle is carrying approximately 8,200 pounds of cargo to the space station aboard the Cygnus spacecraft. And we at Northrop Grumman are very proud of our Antares 230 Plus rocket and are dedicated to providing the best value to our customer in support of our critical missions.
Now, Christina, we're getting some footage from earlier when we were performing that late load capability. This is a good view of that pop-top fairing. From what I understand, Christina, this is near max capacity. We're over 8,000 pounds inside Cygnus. Tell me about how Antares is ready to carry such a mass to the International Space Station.
Yes, Gary, you're correct. Cygnus is near max capacity at 8,200 pounds for this mission. The Cygnus team has been preparing the last few years of an upgraded system to not only add more cargo, but also add more capability to the spacecraft itself to support powered payloads. Cygnus has implemented additional communications and telemetry equipment to connect scientists with their experiments throughout the mission from liftoff to arrival at the International Space Station. All of these enhancements point us toward a long-term goal of growing Cygnus capabilities beyond the space station resupply missions. We also see Cygnus as a strong building block and valuable commercial partner for the next generation vehicle that will go to the moon. And Gary, as you mentioned before, Cygnus, we're so happy that we're able to honor Katherine Johnson for this mission and named her for NG-15. You know, as you mentioned before, Katherine Johnson was an amazing NASA mathematician, and she broke many barriers, including race and gender, while working for NASA and delivered critical calculations for a very important mission that happened on this day. I just also want to mention, you know, as a Native American and from the Navajo Nation, Katherine Johnson was an inspiration for me and countless others to pursue degrees in aerospace, in the aerospace industry. So I'm very honored to be part of the Human Exploration Program, and I also hope to inspire others as Katherine Johnson has to reach the stars when setting their goals. So very happy to be here.
Very good. Christina Halona, thank you for joining us. We'll come back to you here shortly to walk us through some of these upcoming milestones we have, including counting down to that launch mark at 12:36 p.m. Eastern, and, of course, walking us through ascent. We're going to go through some of the great cargo on board. This is a nice graphic that shows exactly what's on board Cygnus. We're talking over 8,000 pounds, nearing 8,400 pounds of cargo, including pressurized and unpressurized. You can see just more than 2,400 pounds of that are scientific investigations, and there are quite a number of them. First is the Spaceborne Computer 2. Now, due to a need to prioritize reliability over performance, computing capabilities in space are reduced compared to capabilities on the ground. This can create challenges when transmitting data to and from space. Although relying on ground-based computers is possible for exploration on the Moon or to low Earth orbit, the solution will be a little bit more difficult for exploring farther into the solar system. So in 2017, the Spaceborne Computer study ran a high-performance commercial off-the-shelf computer in space with the goal of having the system operate seamlessly for a year. It successfully performed more than 1 trillion calculations per second for 207 days without requiring a reset. The Spaceborne Computer 2 will build on the success of this first study, exploring how off-the-shelf computer systems can advance exploration by processing data significantly faster in space with edge computing and artificial intelligence. This experiment plans to demonstrate that Earth-based data processing of current station science data can instead be performed on the station. Eliminating the need for researchers to send the raw data back to Earth for analysis could speed scientists' time to insight from months to minutes. We'll also have some space worms heading to the International Space Station. Tiny worms could help us determine the cause of muscle weakening that astronauts can experience in microgravity. Astronauts work out for more than 2 hours a day aboard the station to prevent bone and muscle loss caused by living in a microgravity environment during long-duration missions. Thanks to a new device for measuring the muscle strength of tiny C. elegans worms, researchers with the Micro 16 study can test whether decreased expression of muscle proteins is associated with this decreased strength, and these results may support new therapies to combat the effects of age-related muscle loss on Earth. Now, of course, some of these investigations are scientific, and some of them are technology demonstrations meant for exploring farther into the solar system. There's an investigation called AHOS. The International Space Station serves as a testing ground for technologies we plan to use on future Artemis missions to the Moon. Now, the AHOS investigation from NASA puts to the test some tools planned for use on the crewed Artemis 2 mission that will orbit the Moon. Built as a primary radiation detection system for the Orion spacecraft, the Hybrid Electronic Radiator Assessor, or HERA, was modified for operation on the space station. Verifying that HERA can operate without error for 30 days validates the system for crewed Artemis mission operations. A related investigation, ISS HERA, which you're seeing now, flew in 2019 aboard the station. ISS HERA provided data and operational feedback in preparation for the Orion spacecraft's upcoming crewed Artemis 1 mission. Uncrewed Artemis 1 mission. There's also another technology demonstration to upgrade the environmental control and life support systems. This is a system of regenerative life support hardware that provides clean air and water to the space station. The system will get an upgrade thanks to the Exploration ECLSS. That's environmental control and life support system. This is the brine processor assembly. The investigation demonstrates technology to recover additional water from the urine processor assembly using a membrane distillation process. Now, long-duration crewed exploration missions require about 98% water recovery, and there's currently no state-of-the-art technology in brine processing that can help achieve this goal, but this is one step closer. The brine processor assembly plans to close the gap for the urine waste system on the space station. Now, these are all investigations going to the space station. We have another one that's actually going to be deployed shortly after the second stage ignition. NASA, in partnership with Virginia Space, is helping launch 30 ThinSats built by elementary to high school and university students that will deploy from the second stage of Antares once it reaches low Earth orbit. These projects not only deliver scientific data, but also help shape a new generation of scientists and engineers. ThinSats will be released from the second stage shortly after launch and will transmit data for approximately 5 days before deorbiting and burning up upon re-entry into Earth's atmosphere. Again, currently tracking no issues to launch. Antares and Cygnus looking good at the Mid-Atlantic Regional Spaceport on Pad 0A. You're looking at a live shot from Virginia. Now, on top of the scientific investigations and the technology demonstration hardware is some fresh food. The astronauts aboard the International Space Station can be expecting some cherry tomatoes, some apples, and navel oranges. They'll also get some cold stowed cheese, Parmesan, and sharp Wisconsin cheddar. Christina Helona, we are coming up on 20 minutes to launch, counting down to the launch window opening at 12:36 p.m. Eastern, 12:36 and 49 seconds. That's at the opening of the window. Tell us about some of the milestones that Antares has gone through up until this point and will go through to the T0 mark.
Sure, Gary. So approximately 5 hours ago, of course, our amazing launch team arrived at Wallops Island in Dulles, Virginia, and Chandler, Arizona, in preparation for launch. The team at the launch pad will also went through their checks prior to evacuating the site, and then shortly after, we went through our pre-power-up verifications right before we power up the Antares vehicle. Once we power up Antares, we run various tests and checks to ensure all is working well on the vehicle prior to doing our propellant loading. The team also gets various weather updates and range updates to ensure weather and range is clear for launch as well. At this point in time, it's about 10:17 a.m. We're just finishing off the tail end of the propellant loading operations. Once this is complete, the team will top off the propellant and we'll do some fuel adjustments. Then we'll do a final go, no-go poll. It's completed, and we'll proceed to the final countdown to launch. And then at approximately 3 minutes prior to launch, you'll hear that the auto sequence was initiated. This is where the Antares internal flight computers take over and commands the vehicle. The auto sequencer then goes through the final steps of prepping the vehicle for launch, and we'll proceed through the final countdown and launch off.
And those milestones all coming up here very shortly. Christina, now take us through ascent. From the moment of liftoff, what can we expect to see?
Okay, so Antares will have a stage 1 ignition at T-0, and we'll lift off shortly after. The main engines will burn for approximately 200 seconds, and then we'll go into MECO. And if you hear MECO, it stands for main engine cutoff. So once we get to MECO, we'll go into a short coast right before we separate stage 1 from stage 2, which we call the upper stack portion of Antares. We'll continue to coast a little bit longer for about 30 seconds before fairing separation, and then we'll have an internal separation where the stage 2 flies out of the external upper stack. Once that stage 2 is clear of the upper stack, the stage 2 ignites for a 2.5-minute burn that puts Cygnus real close to the orbit that they need to be in, and then we'll coast to ensure everything is stable, and then Cygnus will be released into the desired orbit. After Cygnus is released, we'll go through some comm checks, and then about an hour to an hour and a half later, we'll separate, and Cygnus will release its solar arrays and be on its way to the International Space Station. So, in summary, it takes approximately 9 minutes to get Cygnus into orbit.
That's right, and we'll be providing coverage throughout that time until we have an orbital insertion. At that time, we will break our coverage, but we'll still be here in Mission Control Houston monitoring the solar array deployment. That takes place a few hours later, and confirm that over some of our social media sites and our blog. Make sure it is receiving enough power. Now, it's going to spend, Cygnus will spend about a day and a half in orbit, catching up with the International Space Station. It's scheduled to be captured by the robotic arm of the International Space Station at 4:40 a.m. Eastern Time, 3:40 a.m. Central Time on Monday, February 2nd. The robotic arm operators on board the International Space Station will be JAXA astronaut Soichi Noguchi. NASA astronaut Mike Hopkins will be backing him up from inside the cupola. For that coverage, we'll be starting at 2 a.m. Central Time, 3 a.m. Eastern, assuming an on-time launch today. Again, that capture time 3:40 a.m. Central, 4:40 a.m. Eastern. Once Cygnus arrives on orbit, it'll be one of the several visiting vehicles to be attached to the International Space Station. After it is captured by Soichi Noguchi, robotic operators on the ground will take control of the robotic arm and affix it to the Unity module on the nadir side. You can see there, sort of at the center of this configuration of the International Space Station, there are two crewed vehicles aboard. You see on the left the Crew 1 Dragon that carry the NASA SpaceX Crew 1 mission and the 4 astronauts aboard to the International Space Station, and the Soyuz MS-17 carrying Kate Rubins and the 2 Russian cosmonauts to the International Space Station. And, of course, the Progress vehicles currently attached, 77, which just arrived earlier this week on Sunday, and on Progress 75 attached to the aft end of the International Space Station.
Countdown 1.
Go, Core 1.
Step 385, fuel adjustment is not required.
Copy 385. Prop 2, configure OCCS for no adjustment to fuel level.
And in work. And LC Prop 2, OCCS configured for no adjustment to fuel level.
Copy that. Check 386. And admin 387 is not required. And launch team be advised 388 is not required.
This is Mission Control Houston coming up inside 15 minutes, counting down to 14. We're still tracking our launch at the opening of the 5-minute window, 12:36 and 49 seconds p.m. Eastern Time over in Virginia, 11:36 a.m. Central Time here in Houston. Again, everything is still looking good. As Christina Halona described, they're topping off some of the fuel in the Antares rocket already loaded with that liquid fuel, RP-1 kerosene, and liquid oxygen, billowing off some of the conditioned air into the 32-degree Fahrenheit weather out there at Virginia. Still at about 75% favorability for launch today.
LC, this is CMD. Cygnus is in launch mode and nominal. Copy that, CMD. And launch team LC countdown 1. At this time, I'm going to poll to proceed with final countdown. GSO?
GSO, go.
RSO?
RSOs, go.
TD?
TDs, go.
Prop lead?
Prop leads go.
Stage 1?
LC, stage 1 is go. Helium topping is ongoing.
Copy that. Core 1?
In honor of Alexander Diktarov, the late Director General of the Yuzhnoye Design Office, whose efforts in international spaceflight have contributed to the success of Antares, Core 1 is go.
Copy, Core 1. MES-1.
MES is go.
GC.
GC is go.
And ACE.
ACE is go.
Mars.
Mars is go.
CMD.
CMD is go.
LD.
LD is go.
NG.
Northrop Grumman is proud to honor NASA mathematician and space visionary Katherine Johnson, whose computational brilliance and relentless pursuit of excellence set the standard for 60 years of NASA mission success. Katherine humbly yet forcefully broke the barriers of gender and race to enable the future of human space exploration and in the process inspire generations. On this anniversary of John Glenn's historic Friendship 7 flight, which would not have been possible without Katherine's calculations, Northrop Grumman and the SS Katherine Johnson are go for launch.
Copy, NG. Launch team is go to proceed with final countdown. Check 393.
Coming up on 11 minutes to launch. You just heard that poll. We are go for launch. Again, continuing to watch that weather, but targeting still the opening of our 5-minute window at 12:36 and 49 seconds p.m. Eastern Time. Christina Halona, if you're still with us, hearing some of the words coming from the Mission Operations Center and all the teams working so hard on this mission, tell me about some of your thoughts as we're coming up on inside 10 minutes to launch.
Hi, Gary. Yeah, so our teams spread out all across the United States in Wallops, Dulles, and Chandler. The entire team is, in these final moments, are looking at our various telemetry data to make sure the health and status of the vehicle are within constraints. As you just heard, there was a no-go poll of our Antares chief engineers, safety officers, and leaders to continue the countdown. And we'll continue to monitor the telemetry stream and make sure Antares is healthy and ready to go for launch here in a few minutes.
And we're coming up on that shortly. Vehicle systems look healthy, and we're still 75% favorable. And again, we're targeting the beginning of that 5-minute window. So now that we've conducted that final go no go at the T-minus 10-minute mark, we'll be counting down to about T-minus 5. Antares will switch to internal power at that time, and just a little more than 3 minutes will be the auto sequence handoff to terminal count. The computers will take over for the final steps to get us to launch at the opening of that window.
Ops 1, ACS VDMs, internal power on.
VDMs enabled, voltage nominal, ODM commands are clear.
Copy, all LEC 1. Check steps 396 and 397. And T-minus 8 minutes. Mark.
LC site control GN2 conditioning initiated.
Copy, site control. Check 399.
Inside 7.5 minutes, you're hearing some of those countdown milestones. Internal power has been activated. It will be switched here shortly for the Antares vehicle. The International Space Station is currently flying 262 statute miles over the middle of the Atlantic Ocean, just east off the coast of Brazil.
And LC, this is top lead, VTSO activation verified.
Copy that lead. Check 400, Ops 2, 401, initialize ground ordnance power supplies.
LC Ops 2, ground ordnance power supplies initialized.
Roger that.
Like 1 confirms, ground ordnance power supplies nominal.
Copy like 1, check 402. T-minus 6 minutes. Mark.
Now inside 6 minutes to launch. Again, targeting the beginning of the 5-minute launch window at 12:36 p.m. Eastern Time. Christina Halona, as we enter these final minutes up until launch, any final words before we let you go and follow the operations for launch today?
No, I'm just thankful to be here, and I appreciate the invite, and I'm looking forward to successful launch. Go Antares.
Ops 2, LC, step 404, you go to initiate engine priming at T-minus 5 minutes.
LC Ops 2, engine priming started.
And Ops 1, transfer avionics to internal power.
Avionics, internal power on. External power off.
Now inside 5 minutes to launch, Antares is now switched to internal power. Christina Halona, thanks for joining us today. But of course, she's going to be busy over these next critical milestones here. Now that we're inside 5 minutes and switch to internal power, the next major milestone is coming up just a little over 3 minutes. We'll begin the auto sequence handoff to terminal count. The computers will take over, and Antares will be counting down with those computers automatically to launch, targeting again 12:36 and 49 seconds p.m. Eastern Time.
LC priming verified.
Roger that. MES-1, we'll check 412. And we're now in terminal count. Phase 3 dynamic limit will be active at T-minus 3 minutes.
3 minutes and 15 seconds until launch. Terminal count targeting that exact liftoff time, 12:36 and 49 seconds. Tanks will be pressurized at about T-minus 40 seconds, and we'll be counting down to T0. Everything's good for launch today.
Auto sequence start. ODM bus voltages and currents in Holland.
Copy all, like 1. GNC-1, step 418, verify ready for nav mode.
LC GNC-1, orb nav, ready for nav.
And Ops 2, you go to switch to nav.
LC Ops 2, switch to nav.
Orb nav telemetry verified.
Copy all. Check 419 and check 420. TLM, you can switch link 41 to open loop.
LCTM copy. Link 41 open.
T-minus 2 minutes on my mark. Mark. T-minus 1 minute, 30 seconds. T-minus 1 minute on my mark. Mark. T-minus 30 seconds. T-minus 10. 5, 4, 3, 2, 1. We have engine ignition.
Main engine start. And we have liftoff up in Terry for NG-15 mission. The long flight facility. Engines are at 100%. Attitude, core pressures, and vehicle subsystems are nominal.
The SS Katherine Johnson takes flight on this, the 59th anniversary of John Glenn's Mercury flight, carrying 8,000 pounds of cargo to the International Space Station. Good performance on the first stage so far.
Engines at 100%, all systems nominal. Stage 1 continues nominal performance, engines at 100%. Good core pressures. Engines remain steady, attitude nominal. Max Q, attitude nominal.
First stage passing through the area of maximum dynamic pressure on the rocket. 90 seconds into the flight. This first stage burns for a little over 3 minutes, 3 minutes 18 seconds until main engine cutoff.
About 90 seconds to stage 1 burnout. Attitude nominal. Engines at 100% and steady. T plus 2 minutes. All subsystems continue in nominal performance. All subsystems are nominal. We'll be ready to shift down to 80% on the engines at 170. Start up slow throttle down.
Throttling down at 3 minutes into the flight. Main engine cutoff coming soon.
Throttle down to 55%. Main engine cutoff.
We have MECO. Antares entering into a coast stage. Fairing separation will occur about 30 seconds later. As we lose sight of the vehicle, now switching to animation. Some controlled firings on the interstage of the rocket.
Attitude nominal. Good separation. "20 seconds to stage 2 ignition. All subsystems nominal. Fairing separation. Interstage separation.
Confirmed fairing separation and interstage.
Stage 2 ignition.
Stage 2 ignition confirmed. Stage 2 is a solid rocket motor, burns for about 2 minutes 44 seconds.
Stage 2 will continue to burn for another approximately 2 minutes. Altitude 138 kilometers. Mission time, 300 seconds. Velocity, 4.8 kilometers per second. Altitude, 150 kilometers. All systems continue to perform nominally.
Good calls. 5 minutes 15 seconds into today's flight.
Stage 2 motor pressure, nominal. Attitude nominal. Altitude is 170 kilometers, roughly 1 minute to stage 2 burnout. All stage 2 and GNC parameters continue to be nominal.
6 minutes 15 seconds into the flight, coming up on stage 2 burnout of that solid rocket motor. That'll initiate a 2-minute coast period until second stage separation.
Stage 2 starting to tail off. Roughly 15 seconds to burnout. Stage 2 burnout. Attitude nominal.
Stage 2 burnout, good attitude. We're in a coast period now. Cygnus exposed after that fairing separation, and will continue to carry the second stage with it until about 9 minutes into the flight.
Attitude nominal. Attitude nominal. Expected attitude control system thruster firings received. Continuing on course. Roughly 1 minute to payload separation. Altitude 185 kilometers. Velocity 7.5 kilometers per second. All systems continue to operate as expected. Approximately 30 seconds to spacecraft separation. Attitude nominal. Systems continue to perform as expected. Attitude corrections maintaining expectations.
LCGSO, I just released red team to the pad.
Copy that.
Spacecraft separation.
Confirmed. 9 minutes into today's flight, Cygnus has separated from the second stage.
LC Ace, that concludes our callouts.
Copy that, Ace. Okay, NG-15, excellent job today. Let's go ahead and wrap up through this post-launch checklist. And Prop 1, can you report on status of pulse purging?
Pulse purging has just started.
Copy that. We'll check 430. And GNC1LC, when you have the Antares state factor to the Cygnus POC emailed and confirmed, give me a call back on step 431.
Copy and work.
From the Wallops Range Control Center in Wallops Island, Virginia, some celebratory fist bumps as they successfully delivered Cygnus into orbit, a 9-minute flight on top of Antares from Virginia Space's Mid-Atlantic Regional Spaceport into orbit. Cygnus now flying free. The SS Katherine Johnson in flight will make its 1.5-day journey, just a little shy of 2 days, to the International Space Station, arriving in the wee hours early morning on Monday, February 22nd.
Arm enable rotated, arm enable indication no longer illuminated.
Copy that, Ops 1. And Ops 1, disable your local launch enable button.
Ops 1, launch enable removed.
Flight controllers in Dulles, Virginia, Northrop Grumman's Mission Operations Center will take control of the Cygnus and monitor its approach to the International Space Station over the next couple of days. Solar array deployment coming in a couple of hours. Will be breaking before that, and we'll provide confirmation of that via our blog and social media. Before we depart with you today for our coverage of the launch of Northrop Grumman's CRS-15 mission to the International Space Station, we're bringing on Deputy Manager of the International Space Station Program, Kenny Todd, on with us to provide some remarks. Kenny, thank you for joining us today.
Hey, Gary. Good morning. It's good to be with you.
Kenny, this launch comes ahead of a crew rotation and, of course, in the nearer term, some EVAs. From the perspective of the International Space Station Program, what is the significance of this mission, CRS-15?
Well, Gary, I mean, this particular mission has about 8,000 pounds of cargo coming to the space station, and roughly a third of it is going to be dedicated directly to utilization and science on board the station. And so, again, that's our bread and butter. That's what we're up there to do is really do the utilization and science that our commercial customers need, the things that we need to learn in order to go further into our solar system, our human research. And so we've got a lot of this flight that's dedicated to that kind of activity. In addition to that, we've got a little over a third of it that's dedicated just to basic vehicle systems maintenance hardware and some new technology that we're bringing on board. So again, as we look to go further away from low Earth orbit, the thing that we have to do is continue to learn about the systems that we're going to need, and the ISS provides a great platform for that. So we are launching some new hardware in the vehicle systems area that allow us to demonstrate some of this technology and ensure that it'll be there for us when we need it in the future. But then, as always, these Cygnus flights are very important to us because they bring up a lot of crew supplies as well. They are a workhorse when it comes to to making sure that we keep our crews sustained on orbit with the different consumables that they need. So, again, a very important flight for us, and we're glad to see it off the ground and on the way to station.
Off the ground and on the way to station on time, Kenny. This is coming right on the heels of Texas having some severe winter weather. Now, how were International Space Station operations?
On the day that it arrives, we got some key science objectives that we want to get going in that first couple of days. So the first 2 or 3 days after it gets there, we'll be heavily and intensely focused on the science that we need to get up and running. Then shortly after that, merely 4 or 5 days after that, we'll be heavy into doing a set of EVA preps. We're at this point planning on going out to do an EVA in the possibly as early as next weekend. We've got a double EVA planned, and so we'll get busy on that as quick as we get the Cygnus, get the science up and going that came up in Cygnus, and then we'll be on to doing EVAs.
A lot coming up here in the near term. Kenny Todd, thank you so much for joining us here at the end of our launch coverage.
Thanks for having me, Gary. I appreciate it.
Again, we had a successful launch of Northrop Grumman's CRS-15 mission on time today, 12:36 and 49 seconds p.m. Eastern Time. You're getting a live look at the Mission Operations Center in Dulles, Virginia. Northrop Grumman flight controllers taking control of the vehicle and will monitor its approach to the International Space Station over the next near 2 days until it arrives in the early morning of February 22nd, Monday morning. Robotic operators Soichi Noguchi and Mike Hopkins aboard the International Space Station will be poised at the controls of the Canadarm2, the robotic arm of the station, ready to capture it when it arrives Monday morning. The Cygnus is in orbit right now, but its solar arrays are not deployed. We will be wrapping up our coverage and providing confirmation of that solar array deployment here in the next couple of hours, and that it is receiving power and well on its way to make that journey to the International Space Station. Our coverage on Monday morning will begin at 2 a.m. Central Time, 3 a.m. Eastern, to monitor the approach and capture of Cygnus and the 8,000 pounds of cargo inside of the vehicle, and we'll also be providing coverage of the installation process. Robotic operators on the ground will take control of the robotic arm and maneuver into position on the nadir side of the International Space Station, the Unity module, where it will remain for the next several months into May before it departs with trash and science on board to be eventually burned up in the atmosphere. From Mission Control, Houston, and from all the teams that supported the launch, that'll wrap up our coverage of the CRS-15 mission today. We'll be with you again on Monday morning. Until then, this is Mission Control, Houston.